Hello, I will present one of the latest tools I've been working on for Ableton. This one is a quantizer. Let me show you an example of what it does. So this is a badly quantized piece of music. I could want to quantize it with the usual tool from Ableton. It will do something like this. It's strictly quantized, but then all the grace notes and arpeggios and stuff like that are quantized as well, which is probably something that you don't want. I could reduce the amount of quantization, but then all the notes that actually need to be strictly quantized, such as this one, will be moved as well further from the quantization point. And now let's see how the tool handles the same melody. You could notice that this note is now nicely quantized, but some of the melodic contours are being kept mostly intact. I created this as a request from somebody called Yeha who had been using Logic Pro, and apparently they have something in Logic called smart quantize or smart quantization. I don't use Logic, so I'm not sure what it is, but I tried to create a tool that would replicate what I understood this tool was from textual descriptions. I tried to settle for default values that would make sense most of the time in most scenarios I've encountered while testing, so that you could just not care about the buttons and just transform anything. But it's hard to find values that would work for every scenario. So sometimes you will have to tweak those knobs a bit, and I'm going to explain in a moment what each of them does. If you wanted to have a quantization that would act just like the standard quantization, what you should do is doing normal algorithm, duration you could say keep, set freedom to the maximum, set smooth to 0, and there you have the normal quantization. This part here is obviously the grid that the quantizer is going to use. So 16th it matches the current grid in life. You could divide the grid further, like have triplets or quintuplets or anything up to 97. This is a divider, so it divides like this is 1 bar and this is 1/3 of a bar, and etc. You could also want to have swing. This is swing. You can also do reverse swing or extreme swing, but the normal swing value would be something like 0.2, I suppose. The tool will let you choose between several algorithms. I will start with the normal one, which is the usual way a quantizer works. And from there, I will show you what the freedom button does. To do so, I will choose a grid of one entire bar. If I let the freedom knob to 1, everything will be quantized. The freedom knob acts as a kind of threshold. If I set it to 0, nothing is quantized. And as I move it up, it will allow certain notes to be quantized, only if they are close enough to their closest quantization point. Then there is a duration drop-down menu. If I set it to keep, it means that each note will move, but the duration of each note will stay the same. If I set it to adapt, it means that the note ends will be interpolated between the note starts. I should add a new note to explain what I mean by this. This mode guarantees that whenever two notes overlap, they will still overlap. Whenever there is a gap between two notes, the gap should still be there after quantization. And the third option is quantize. It quantizes the note ends. For now, the third option quantizes the note ends no matter what the other knobs say. Then you have this button called smooth. And I think this button is very interesting, and I will try to explain what it does using Microsoft Paint. Imagine that you have a timeline like this. On this timeline you have quantization spots, like a grid. And then you have nodes. I will represent nodes with orange markers like this. So yeah, you have nodes. And then you want to quantize those nodes. So this one is already quantized. It's fine. This one is a bit early. So if you want to quantize them, you should move it forward to this point here by this distance. But I will represent the distance with a vertical line pointing up because it needs to be moved forward. This one also needs to be moved forward, but by a greater distance. So I will do an arrow pointing up by a greater distance. This one needs to be moved backwards by some distance. So I will do an arrow pointing down. This one should move forward like this. I'm doing it quickly, like this, this, and like this. And now you have all those green lines. And one way to see this is to imagine that is to connect all the green lines together. And if I connect all the green lines together, it will create some kind of signal that evolves over time. Like this. You could see this as a kind of, as if it was some kind of audio signal. If the signal is flat, it means that all the notes are already quantized and it's fine already. If the signal is, pick another color, if the signal is something like this, like a low frequency, it means that all the notes are late in this part and all the notes are early in this part, but you could move mostly all this block together and all this block together and it will be okay. But the problem will arise if you have something like this. If you end up with something like this, for some reason, it means that the notes are going to move backwards and forwards in every direction very quickly, one after each other, and it's probably bad. It's probably something that you don't want. So in the end, like imagine that I will just fake the grid signal and imagine that at some point you have high frequency like this and then you have low frequency. You could use some kind of low pass filter to filter the green signal and keep only the low frequencies and filter out the high frequencies. You will end up with something like this, Whoop. I'm not exactly sure. No, it should be more like something like this. And then, once the signal is filtered, I resample the I will resample the quantization, like the displacement values, based on the new filtered curve. And the actual way knots are going to move will be based on this curve. And like the actual way will be the blue lines. Sorry, it's a bit messy. I'm using what you would call like a FIR filter. So I need a window, and you can choose the shape of the window. I did that mostly as a test because I didn't know which window was best. I settled for Gaussian, but I'm still not sure. A lot of these options are probably going to disappear in the final version of the tool, but right now I need a lot of feedback and testing, so I'm keeping everything. The value of this parameter, this knob here, is actually the length of the window multiplied by the length of the grid, which means if I set this to 1, I currently have a window of 1/16 bar. If I set it to 1, I have a window of 1 bar. If I set this to 0.5, I'm using a window of half a bar, etc. Ooh. I know that it might sound like the smooth parameter is simply moving the knots from their original position to their quantized position, which is already what the strange parameter does. But it's actually a bit different. For instance, the smooth parameter will smooth knots that are very close to each other first. But if I have another knot that needs to be quantized but is isolated from the other knots, then it will keep them quantized. And lastly, I will probably explain what all the alternative algorithms do. Some of them are a bit weird, and I might want to remove them once I'm done with the testing phase. But I will explain all of them. So the group one and all the snap ones have all something in common. They all give a special treatment to knots depending on if they overlap or not. Like these knots don't overlap. This group of knots overlap each other, so it's being treated as one group. For instance, the group one is almost like the normal algorithm, except that it applies smoothing only on separated groups of nodes. For instance, this is the quantized version, and smoothing is applied on this group of polyphonic nodes, unlike the normal algorithm that will apply smoothing on like all the nodes will push each other, like they will interact with each other, no matter if they are being played at the same time at some point or not. So, then there is all the snapping algorithms. I will use these arpeggios to demonstrate it. All these algorithms will treat groups of nodes, groups of overlapping nodes as a whole, which means it will act as if this was one big knot, and it will just move it as one block. It will move it in different ways. For instance, I will snap it on this duration. Here, it will consider the first knot to be the starting point of the group, and it will just quantize the first knot of each group. group like this to the quantization spot. I can also snap the center point between the first and the last node, and there are other options. Median, like as many nodes before than after. Mean is kind of weighted center, like a center of gravity, if you want. Last snaps the last node of each group. And best is, I don't remember what is this one. Yeah, best is it will snap the node that is closest to the quantization point. Like in this case, this is this one and this one. So it will snap so that the group will not move too much. And then there is the greedy algorithm that I consider so far to be the best one, or the more subtle one. And what will I use to explain this one? So, how does the greedy method work? First, let's say that I want to quantize this group of 4 nodes to the 16th of a bar, which is this and this spot. First, the algorithm will make a list of all the nodes. And it will see for each node if it's close to the closest quantization point or not. So in this case, this one would be very close. Then the second item of the list would be probably this one. Then this one, close to the next point. And probably this one last, which seems to be mostly in the middle. So it will start with the top of the list, and it will move this node first to the closest quantization point. And then it will move to the second node, but it will see that there is already one node that has been quantized here. So it will not be able to use this one as the second option. So it will use the third option instead, and it will move the third option to the closest available spot. But by doing so, it will stretch all the nodes that are in the middle. So it will do it like this. I think. Let's try. Yes, it does it like this. So you might think that it would be dangerous to snap only one node to each spot, and it is, but not as much as one might think. For instance, if I have two or more nodes here, it will only snap one of them to the point and leave this one free. But since it will stretch everything, then that means that the simultaneous nodes will still be simultaneous. So it will keep chords intact. But the difficult case, the edge case that is difficult to handle is if you have something like this. Because it will snap this one first, and then it will try to snap this one, but it will be unable to snap it to this point, so it will possibly snap it to this point. Or it will not, no, it will first snap this one, then it will be unable to snap this one, then it will do this. And that's probably not something that you want. Let's try. Yes. So in order to solve this kind of case, you could either use the smooth parameter or simply use the freedom parameter. Yeah, if you set it low enough, it will prevent nodes to be snapped to a point that is too far away, that doesn't make sense. Usually if you try to snap a point to somewhere that is more than half the current grid, it means that something is wrong. So I it's usually safe in any case to leave this low. Oh, and I realized I forgot to mention this little, it's really kind of an Easter egg or something. It's a tiny button, but if you press it, it will invert the quantization, which means it will exaggerate the irregularities instead of correcting them. So let's try with these values, whatever they are. This is the quantized version. And then let's hear the inverted version. Yeah, cool. I don't know how this can be used, but I will now release this version of the tool as is. And yeah, I will try to use it, and hopefully I will receive some feedback as well. And maybe I will then correct it and make it more simple. I don't know.